Hello friends, welcome to this video. So today also we are going to discuss another problem. This question which was asked in again 2021 JEE Main. So the question is, let us have a look at the question, then we'll solve it. Okay. The work done by a gas molecule in an isolated system is this one. This is the expression for work done. Okay. So W work done is equal to alpha beta square e to the power minus x square divided by alpha kt. So what are these quantities given? X is the displacement, K is Boltzmann constant, T is the temperature, and alpha and beta are constants. So what is the dimension of beta? Okay, so beta's dimension we have to measure. So remember, dimensions are measured in terms of M, L, and T. Okay, mass, length, and time. Okay, so what is the dimension of beta provided all this information are given in the question? Okay, so work done is this quantity. So before we solve this problem, let us analyze this question first quickly. So e to the power this term, e to the power minus x square by alpha kt. Okay, so e to the power something is it's a constant term. Okay, it's a number. Sorry, so not constant. It's a number. Okay, e to the power something is a number. So exponential to the power something does not have any unit. Okay, it has got no units, so it's a number. So this power of this exponential here, whatever is given, minus x square over alpha kt. Okay, minus x square over alpha kt. This is a number, just a number. Number means it has no dimensions. Okay, it's a number and it has no dimensions. So once again, e to the power something exponential to the power something is a number. So so that this exponential term is a number, the power of the exponential should also be a number, and that means this x square over alpha kt term has no dimensions. Okay. So whatever this W value is given, so W is equal to alpha beta square. So this term will have the dimensions. Okay, so this alpha beta square. So we need to calculate the dimensions of this quantity. So work done's dimension we know. Okay, we know what is the dimension of work done. So we are required to calculate the dimension of beta. Okay, so in order to calculate the dimension of beta, we have to first calculate. Okay, first calculate or determine the dimension of alpha. Okay, so let us solve this problem. Let me open my board. So just a minute. Okay, just a moment. So I have to clear all the drawings. So let us solve the okay, let us solve the question here. So x to the power x square divided by alpha kt. This quantity is it is a number, so it is dimensionless. Okay, so let us solve this one first, and then and from here our target is to find dimension of alpha. Find dimension of alpha. So how we can do it? Okay, so x is given to be the distance. Okay, so that means it will have a dimension of m0, L square T0. Okay, that is the dimension of x square divided by alpha kt. Alpha we'll have to calculate, alpha we'll have to find out. So it will be alpha kt. K is Boltzmann constant. So again, what is the unit of Boltzmann constant? The unit of Boltzmann constant K is Joule over Kelvin, temperature. Okay, so it is not time here, it is Joule over temperature in Kelvin. Let me write it as okay, let me write it as T. Okay, this T and these dimensions T are different. Please remember that. So you see here KT. Okay, if you multiply KT, that means if you Boltzmann constant and temperature are multiplied, we get Joule. Okay, the unit of energy. So this KT will give us the energy. Okay, J. So instead of writing this as J, we will simply write here the dimension of J. So J is the work done. So J is the work done. What will be the dimension of J? Work done is equal to force multiplied by work done is equal to force multiplied by distance. So we can write this as M1, then L1 multiplied by L being the dimension of distance. So M1 L2 T minus 2. So the dimension of work done is M1 L1 T minus 2. So here in place of KT, okay, since KT gives us the work done J, so here I will write the dimension of the work done, okay, because here we are dealing with the dimension. So M1 L2 T to the power minus 2. Okay, so this quantity, we have written the dimensions. So alpha's dimension we have to calculate. So this quantity is dimensionless. Dimensionless means M0, L0, T0. Okay. So what is the dimension of alpha? So dimension of alpha is M0, M0 get cancelled here. So T0, T0 get cancelled here. So L is 2L to the power 2 get cancelled here. So dimension of alpha, if you take alpha to this side, so here it is L0 anyway. So dimension of alpha would be M minus 1 T2. Okay, M minus 1 T2 is the dimension of alpha. Okay, so this way we have been able to calculate the dimension of alpha from this quantity. So very important, because this dimension of alpha will be required when we will be calculating the dimension of beta. So now see here, exponential term we are no more writing, because exponential term is a number. So let us, so W is equal to alpha beta square. Okay, so what is the unit of work done again? Unit of work done. So Joule, that is also the unit of work done. So we can write it as M1 L2 T to the power minus 2. Alpha unit, alpha's dimension is M minus 1 T2 and beta square. Okay, so what will be the beta square value here? So it is M1 M minus 1, so this one would be M2. L, there is no L term, so it will be L2 as it is. So T minus 2 here, T squared, that would be give us T minus 4. Okay, so what would be the so it is beta square is equal to M2 L2 T minus 4. Okay, so what would be the unit of beta? Beta's unit would be MLT minus 2, because just take the square root of this quantity. Beta square has a square root of beta, square root of this quantity, M square, square root is M, L square square root is L, T to the power minus 4, square root is T to the T minus 2. Okay, so in other words, M1 L1 T minus 2. Okay, so the dimension of beta is M1 L1 T minus 2, okay, M1 L1 T minus 2. So this is how you can solve such a problem. Once you know the dimensions of the given quantities and you have a look at the question, the exponential term is a number. So that way, first calculate the dimension of alpha, and then from this relation, because exponential term is a number, it's a dimensionless quantity. So we can calculate the dimension of beta. So this question was asked in again, so very conceptual question, and was asked in JEE Main 2021. I hope you understood this solution. If you have any questions and comments, please type in the comment section. And thank you very much for watching this video. Please subscribe to this channel, share the video, and see you in the next video. Thank you very much.